All right, get ready to dive in. Today we're exploring what it takes to be a lead software engineer building those crazy, complex enterprise AI platforms.
It's a wild world out there for sure.
And to make it even more interesting, we're using a set of real interview questions for that exact role as our source material.
Oh, that's a great idea. Talk about getting into the nitty-gritty. What's cool is how these questions reveal way more than just coding skills.
Oh, yeah.
It's about the whole ecosystem, from designing the systems, making sure they perform well, all the way to understanding those AI integrations.
Okay, so let's crack open this treasure chest of questions.
Yeah.
Right away, we get hit with questions about structuring microservices
Mm.
and making sure the system is always available. These aren't your run-of-the-mill coding puzzles, right?
No, not at all. These are big picture things a lead engineer absolutely needs to understand. It's like, imagine you're an architect designing a whole city.
Okay, I like where you're going with this.
You've got to understand how all the different parts are connected, how they all work together smoothly, especially when you're dealing with all the demands of AI applications.
So it's not just about writing super clean code, it's about designing systems that can grow, adapt, handle whatever gets thrown at them. Kind of like building a self-driving car.
I like that, yeah.
You need to think about every possible situation and make sure that system can handle it all safely and efficiently.
Got it. And speaking in crucial details, question 8 throws a curveball, API versioning.
API versioning. I can see how some people might think, why is that so important?
But honestly, in the world of AI, things are moving so fast.
Oh, yeah.
Managing those API changes, without breaking everything, it's super critical.
Right, because as those AI models get better and new features come out, you don't want to leave all your existing integrations in the dust. It's like future-proofing your platform, making sure it can handle all the amazing AI advancements that are happening all the time. But let's be real, things are going to break, right?
Happens to the best of us.
No matter how well you plan. Which brings us to question 10 debugging performance bottlenecks. Every engineer's nightmare.
Oh yeah, you said it. And those bottlenecks, they can be even worse in the AI world. Imagine a self-driving car,
All right.
and it hesitates at a crucial moment because of some performance glitch. Not good.
Nope.
That's why a lead engineer has to be like a master debugger. They've got to be able to analyze performance data, find those bottlenecks, and come up with smart solutions.
So it's not just about finding the bug itself. It's about understanding how that bug affects the whole system.
Right, the bigger picture.
Especially in high-stakes situations like AI. Okay, we've laid the groundwork with those core full-stack concepts. Now let's zero in on the front end, where users actually experience the magic of AI firsthand.
Love it. And these interview questions jump right into the heart of front-end development, focusing on React and Next.js, the powerhouses behind a lot of those awesome web applications.
Question 12 caught my eye right away. React server components. They sound cool, but what are they all about, and why should our listeners care?
All right, so picture this. You're building a complex dashboard.
Okay, got it.
To visualize all those insights from your AI, traditionally, all that rendering would happen in the user's browser,
Uh-huh.
which can make things slow, and the user experience isn't great.
Right. Nobody wants a slow website.
Exactly. Server components kind of flip the script.
Okay, I'm intrigued.
They allow you to render parts of the application on the server and send it to the browser as already rendered HTML.
So it's like giving the user a head start, taking some of the load off their browser.
Yes, exactly. It's all about making things run smoothly, which is so important when you have all those data-heavy AI applications.
Ugh.
And while we're talking about optimization, the next question digs into a concept that's specific to Next.js. The difference between get server-side props and get static props.
Ah, yes, question 15. Now, I've heard these terms before, but honestly, I've never been totally clear on what makes them different. Could you break it down for us?
Sure. Imagine you're creating an e-commerce site with AI-powered product recommendations. Some parts of the site, like the product catalog, probably don't change that often. That's where get static props comes in. It generates those pages at build time, making them load super fast, and it's great for SEO.
Gotcha. So what about those personalized product recommendations? That's where get server-side props takes over, right?
You got it. It grabs the data every time someone visits the page.
I see.
That way the recommendations are customized for each user.
So it's like having two different tools, each one perfect for a specific situation. Get static props for stuff that doesn't change much.
Right.
And get server-side props for all the dynamic, personalized things that need to be fresh and up to date.
Exactly. And choosing the right one is crucial for making a website that performs well and is easy to use. And it's a perfect example of how a lead engineer needs to think strategically about how data is fetched and shown to the user, especially when you're talking about AI.
All right, we've covered a lot on the front end. Now let's explore the powerhouse behind the scenes, the back end. And in this world, one framework stands out, FastAPI.
FastAPI has totally taken over in the Python world, and for good reason. It's fast, it can handle tons of data, and it has a modern way of designing APIs. And question 21 hits on this directly. Why choose FastAPI over other popular frameworks like Flask?
Right, because with enterprise AI, speed and the ability to scale are non-negotiable. You need a backend that can handle all those complex AI models and huge data sets. So what makes FastAPI so special? What's the secret ingredient?
It's a mix of smart design and the power of asynchronous programming. Imagine a restaurant kitchen. FastAPI is like having a team of amazing chefs, all working at the same time, each one handling different parts of the meal.
Okay, I'm following you.
This way, the kitchen can put out dishes much faster and more efficiently than a traditional kitchen, where one chef does everything one step at a time.
So it's like having a supercharged engine under the hood, making sure your backend can keep up with everything AI needs.
Precisely. And to make sure those APIs run smoothly and reliably, we got to talk about Pydantic models.
Question 25 asks about those. I'm guessing they help make those APIs super robust.
They're essential. Pydantic models are like the blueprints for the data that flows through your API. They define how the data is structured and what types of data are allowed.
It's like a quality control system.
Yes, you got it. Catching errors early on and preventing all sorts of headaches down the line.
So it's like having a team of inspectors checking every single ingredient before it goes into a dish, guaranteeing a high-quality final product.
Exactly. Pydantic models are a huge part of why FastAPI is so powerful and reliable for building those high-performance APIs that are crucial for enterprise AI.
Okay, we have this supercharged backend running, but where do we store all the data, especially for AI? Let's head to the database section. Things are about to get really interesting.
This is where you see how AI's unique needs start to shape the tech we use. Traditional databases aren't always the best fit for the kind of data AI models use. That's why we're seeing these specialized databases pop up, like vector DBs.
Question 36 asks how vector DBs are different from those traditional databases. Can you explain it in a way that makes sense to someone who's really into AI?
Sure. Imagine searching a massive library of code. A regular database might let you search by keywords,
Yeah, okay.
but a vector DB lets you search by the actual meaning of the code, like what it does.
Whoa, so it's like a search engine that understands what the code is supposed to do, not just the words it uses.
You got it. It's a game changer for developers building AI.
Yeah, that's huge.
Vector DBs are changing how we store and access data for AI, making it way easier to find and use the information that really matters.
Speaking of choosing the right tool for the job, there's a question about Redis versus MongoDB for managing user sessions. Why is this choice so important, especially for AI applications?
It's a great question. Question 39 shows us that database choices are strategic. Imagine you're building a chatbot powered by AI that responds in real time.
Okay, cool.
Redis is super fast because it stores data in memory. It's perfect for handling those quick back and forth conversations, making sure the chatbot responds quickly.
So Redis is the speedster, perfect for those instant interactions.
Exactly. Now, MongoDB is more versatile, great for storing the chatbot's knowledge base and user profiles.
So it's like Redis provides the speed for real-time stuff,
Well,
while MongoDB gives you the storage muscle for all the AI magic.
That's a great way to put it. The best choice always depends on what your application needs. A lead engineer needs to understand those trade-offs to make the right decision.
Awesome. Okay, let's take our data-powered platform and launch it into the cloud.
To the cloud.
The next section dives into AWS and DevOps. It's no surprise that cloud skills are super important in the AI world these days.
Oh, absolutely. AI apps often need a lot of computing power and storage, so the cloud is a natural fit. And question 41 jumps right into a specialized cloud skill, optimizing AWS Lambda functions to make them run faster.
Right, those Lambda functions are those little pieces of code that run on demand. But why is making them run faster so important, especially for AI?
So Lambda functions are awesome for building AI applications that are cost-effective and can handle lots of users, but they can also cause delays, especially when they first start up. That's what we call a cold start.
Oh, I see.
Imagine you're using an AI-powered image recognition service, and there's a delay.
Ideal.
That can make the difference between a smooth experience and a frustrating one.
So it's all about getting the most out of those serverless functions to keep things running without any hiccups.
Yes. especially when you're dealing with the demands of real-time AI applications.
Makes sense.
A lead engineer has to know how to optimize those Lambda functions, reduce those cold starts, and make sure the system can handle all those AI tasks efficiently. And speaking of efficiency, we can't forget about keeping those cloud costs under control.
Yes, question 44, the never-ending battle of performance versus budget. Nobody wants to get hit with a massive cloud bill, especially when you're running complex AI apps.
True that. Reducing cloud costs is tricky,
Yeah.
but it's essential. It means picking the right services, using resources wisely, and always keeping an eye on your spending. It's like being a financial advisor for your AI platform, making sure you're getting the most out of your money.
So it's not just about building cool AI applications. It's about building them in a way that's powerful and doesn't break the bank.
Exactly. That's a big part of what makes this lead software engineer role so challenging and rewarding. It's not just about the technology, it's about understanding the business side of things, making smart decisions that help everyone achieve their goals.
All right, we've covered a ton of ground in this first part of our deep dive, from the basics of full-stack development to the special needs of building for the cloud. But we've only just scratched the surface. Stay tuned for part 2, where we'll dive even deeper into the world of enterprise AI.
Welcome back. We're ready to go even deeper into what it takes to be a lead software engineer building enterprise AI platforms.
Okay, I'm all set and ready for round 2. In the last part, we talked about building those foundations. Now I'm curious, what are the special skills that really make this role stand out?
One area that often gets overlooked is integrations. You see, these AI platforms, they don't just exist on their own.
Right.
They need to work smoothly with the tools people are already using.
Yeah, makes sense. It's like building a bridge between your brand new AI platform and the whole universe of enterprise software out there. And talking about bridges, question 65 really caught my eye, integrating Google Drive APIs. What makes that so tricky, especially when you're dealing with AI?
Like a classic integration problem, but AI makes things even more complicated.
Yeah.
Let's say you're building an AI tool that analyzes documents,
Okay, yeah.
and it needs to get those documents from Google Drive. You have to think about security. How do you make sure only the right people can access those files?
Right, security is huge.
You have to deal with all sorts of file formats, sometimes massive amounts of data.
Oh, yeah, definitely.
And of course, you absolutely cannot let sensitive information leak out.
So it's like being a diplomat. You're negotiating a secure connection between your AI platform and Google Drive, making sure no secrets get lost along the way.
Exactly. And speaking of keeping things safe and sound, question 66 takes us right to the heart of security. How do you store and manage those super important API keys?
Right, those API keys are like the master keys to your whole AI kingdom.
They are.
You don't want those falling into the wrong hands.
Absolutely not. You need serious protection, like a bank vault for your digital stuff. You wouldn't leave a vault door wide open, right?
Right.
Same goes for API keys. You need strong strategies. Things like environment variables, secure config files, even special systems just for managing secrets. And on top of that, really tight access controls so only the right people can even get close to those keys.
So it's not just about writing code that's secure, it's about creating a culture where everyone's thinking about security when it comes to those API keys.
That's a great point. Security is an ongoing thing. It's got to be ingrained in how you build and run these platforms.
Yeah.
Okay, let's switch gears a bit.
Okay, sure.
Let's talk about something every developer knows and, well, sometimes loves. Debugging.
Ah, yes. The thrill of the chase. And in the world of enterprise AI, those bugs can be even harder to find lurking in these complex systems.
They sure can.
Question 80 really captures that feeling of dread debugging production issues in a full stack system. It's like trying to find a tiny needle in a giant haystack that's on fire and spreading fast.
Wow, that's a pretty intense image. But it highlights why a lead engineer needs to be a pro at debugging. It's not just about fixing the bug, it's about understanding how that bug affects the entire system.
Right, because a tiny bug in the AI world can snowball into something huge, potentially messing up critical processes or even leading to the AI making wrong decisions.
Exactly. So a lead engineer needs a whole toolkit. Robust logging systems, ways to monitor everything, tools to really see what's going on inside the system, and of course they need to stay calm under pressure and think things through.
So it's a mix of technical skills, being able to analyze things, and having that almost superhuman ability to stay cool when everything's going crazy.
You got it. Debugging, well, it's a real test of a good engineer. And when you add the complexities of AI, it gets even more demanding.
Makes sense. Okay, we've talked about integrations, security, debugging, all those essential but maybe not so glamorous parts of building these platforms. Now let's get back to those AI-specific skills.
Ah, yes. Getting to the heart of it all. Question 82 takes us into the world of vector search. It's a fascinating area.
I've heard the term vector search, but I have to admit it's always sounded a bit like magic to me. Can you break it down?
Hmm.
Especially for someone who lives and breathes AI.
Think back to those vector DBs we talked about earlier. Vector search is what unlocks their true power. It's like having a search engine that understands not just the words, but the actual meaning behind the data.
So instead of searching for documents with the word cat, you could search for documents about feline companionship.
Exactly. And this changes everything for AI. Imagine an AI system that recommends movies. But it doesn't just look at genres, it understands the deeper themes and emotions in the movies. That's the power of vector search.
Okay, my mind is officially blown. Vector search is like having a superpower for finding and understanding information.
And speaking of superpowers, question 85 introduces us to the giants of the AI world, large language models, or LLMs for short.
Ah, yes, the LLMs, the AI that can write poetry, translate languages, even generate code. It's amazing.
Yeah.
But how do you actually use that power for specific tasks? That's where fine-tuning and embeddings come in, right?
You got it. Fine-tuning is like taking a super smart student and giving them a crash course in, say, astrophysics. They're already brilliant, but now they have the specific knowledge to solve complex astrophysics problems.
So you're shaping the LLM to fit what you need, making it an expert in your field.
Precisely. And embeddings are like creating a map of meaning for the LLM.
A map of meaning.
They turn words and concepts into vectors,
Okay.
capturing how those words and concepts are related. So you can ask the LLM, find me everything related to this idea, and it'll understand the meaning, not just the exact words.
Whoa. So embeddings let the LLM understand and think about language kind of like humans do.
Exactly. And this opens up incredible possibilities for building AI applications that are truly intelligent. But we can't forget, AI models are only as good as the data they learn from.
You're right. That brings us to question 86, building a document processing pipeline using NLP. This is where things get real in AI, taking messy data and making it something an AI model can actually work with.
Right. Because in the real world, data is rarely neatly organized and ready for AI.
It's like trying to feed an AI a bunch of raw ingredients instead of a delicious cooked meal. Not very appetizing.
Exactly. And that's where natural language processing, or NLP, comes in. NLP gives us the tools to extract meaning from text. Things like tokenization, part of speech tagging, figuring out what the important entities are, analyzing sentiment. It's like having a team of expert chefs taking those raw ingredients and turning them into something the AI model can actually digest.
So you're taking all that messy data, cleaning it up, and making it a feast for the AI model.
Exactly. A lead engineer needs to know how to build and manage these data pipelines, making sure the data is top-notch, accurate, and consistent.
Because bad data in means bad results out, right?
Exactly. And with all this powerful data processing comes responsibility.
Of course, yeah. Question 87 reminds us about data security, especially for all that data generated by AI.
That's a critical point. AI models can create tons of data. Some of it might be sensitive, confidential stuff. You absolutely don't want that getting into the wrong hands.
Definitely not.
It's like having a vault filled with valuable insights from your AI. You need to have the best security measures in place.
Yeah.
Encryption, access controls, auditing, all to protect that data and make sure it's used ethically.
So building powerful AI systems isn't enough. You have to build them with security and responsibility baked in.
100%.
Yeah.
A lead software engineer in this space has to be a technical expert and a data guardian, making sure AI is used to help society, not hurt it.
Okay, we've covered a ton in this part of our deep dive. Integrations, the art of debugging in complex systems, the power of vector search and LLMs, and the importance of processing data and keeping it secure.
Phew. It's a lot.
It's clear this role needs more than just technical skills. You need a deep understanding of how AI affects the world around us. But there's still more to explore. Stay tuned for the final part of our deep dive, where we'll tackle one of the most exciting areas of AI chatbot integration. We're back for the final part of our deep dive into the world of led software engineering for enterprise AI platforms. We've journeyed through the front-end, back-end databases, cloud infrastructure, the whole shebang. But now it's time to talk about one of the most fascinating applications of AI chatbots.
You know, chatbots aren't just a fun gimmick anymore. They're becoming essential tools in businesses, automating tasks, providing insights, even making collaboration better.
Oh, for sure. I remember when chatbots were mostly just basic FAQ bots. Now they're practically running the show in some companies. And speaking of running the show, our source material wraps up with a bunch of questions about, you guessed it, integrating those AI-powered chatbots into enterprise SaaS products.
And this is where all the pieces we've talked about come together. Front-end interfaces, back-end logic. Those AI models, even those ethical things we discussed earlier, it all comes into play.
Right, it's all connected. Question 69 really stood out to me, integrating AI chatbots with Slack. Seems like a natural fit, but I bet there are some unique challenges, especially in a big, complex enterprise environment.
Oh, definitely. It's not as simple as just plugging in a chatbot and saying, okay, we're done. You have to think about the user experience. How's this chatbot going to interact with all the stuff that's already in Slack, like channels, threads, notifications? Is it going to feel like a natural part of the platform or like some clunky add-on?
Right, nobody wants a chatbot that's constantly interrupting their work or sending them messages that don't make sense.
Yeah.
It has to be smart, seamless, actually useful.
Exactly. And then there's the technical side. Understanding the limitations of Slack's API, dealing with security protocols, making sure your chatbot can handle the huge scale and complexity of an enterprise platform. It's a lot to juggle.
So it's like building a custom-made robot, right? One that can navigate the crazy world of Slack, but also speaks the language of AI.
Yeah, that's a great way to think about it. And speaking of AI, the real challenge is making those chatbots truly intelligent. It's not enough to just program them with a bunch of pre-written responses. You've got to train them on huge data sets, use NLP and machine learning so they can understand what people mean, provide accurate information, and actually get stuff done.
Right. It's got to be way more than just a fancy FAQ bot. It has to be able to have a real conversation, learn from every interaction, and even, like, anticipate what users need.
Absolutely. That takes a deep understanding of how AI works, the ability to work with complex algorithms, and a constant desire to push the limits of what's possible.
So as we wrap up this deep dive, what are the key things that aspiring lead software engineers who are excited about AI should take away from all this?
I think the biggest takeaway is that this role requires a special combination of things. Like what?
Technical expertise, strategic thinking, and a real passion for innovation. It's about feeling comfortable working right where software engineering and AI meet, always learning and adapting as technology changes.
It's not just about writing code. It's about seeing the whole picture, right?
Yeah.
The business needs, what users want, and even how AI affects society.
You nailed it. A lead software engineer in this space. They're a leader, a problem solver, a visionary. They're shaping the future of how we interact with technology.
So for those who are up for the challenge, the possibilities are endless. This field is exploding with opportunities, and the need for skilled engineers who can build and manage these complex AI-powered systems is only going to grow.
No doubt about it. It's an incredibly exciting time to be at the forefront of this tech revolution.
Well, there you have it, folks. Our deep dive into the world of lead software engineering for enterprise AI platforms. We've covered a ton, from the fundamentals to some cutting-edge stuff.
And I hope we've given you a good sense of the challenges, the rewards, and the amazing potential of this ever-changing field. So if you're feeling inspired to jump into the world of AI, remember, never stop learning, never stop exploring, and never stop pushing those boundaries.
Until next time, keep on diving deep.